Hello and welcome. Today, we're going under the hood. We're going to take a look at how the latest AI models actually think. We're going to dig into the deep down design choices that make them so incredibly powerful and also so different from one another. So, let's just get right into it. You talk to AI all the time now, right? You ask it to write an email, dream up a picture, maybe even plan your next vacation. And boom, you get an answer in seconds. But what is really going on behind that screen? Is it thinking? That's the big mystery we're going to try and unravel today. All right, to really get a handle on where we are now, we have to start with the fundamentals. So, first things first, what in the world is a large language model, or an LLM? And how on earth did we get here so fast? Okay, here's the textbook definition, but let's break it down. At its core, an LLM is a kind of AI that basically learns to talk like a human by reading, well, pretty much everything. It analyzes just enormous amounts of text and data. And trust me, when they say large, they mean it. We're talking about models trained on a huge chunk of the public internet. You know, the easiest way to wrap your head around this whole thing is to think of its neural networks as a kind of digital brain. Now, it's not conscious, of course, but just like our brains, it's always forming new connections and learning patterns from all the data it takes in. It's basically getting smarter with every single piece of information it processes. And look, this journey has been a long time coming, but lately progress has just hit light speed. I mean, we went from Eliza, which was a very, very simple therapist chatbot back in 1966, to a huge leap forward with Google's Word2Vec in 2013. But just look at the last few years. From GPT and BERT in 2018 to what we have today, the pace of innovation has become absolutely explosive after decades of just slow, steady progress. And all that rapid progress brings us to right now. We're seeing these two new titans emerge in the AI space. And what's fascinating is that they're each built on a totally different philosophy of what an AI should even be. So on one side, you've got a model designed for just maximum speed and raw creative power. It's like having a team of experts on call for any task you can think of. And on the other side, you have a model that was built from the ground up with safety and predictability as its North Star, put through this unbelievable gauntlet of tests. So let's take a look at GPT-5 first. Its big, game-changing innovation is something they're calling a smart router, and it's trying to solve a huge problem. How do you give people both lightning-fast answers for simple stuff and deep, careful thinking for complex problems, all without making every single chat incredibly slow and expensive? This really lays out how it works perfectly. So you ask it for, say, a simple summary of an article. A real-time router inside the system instantly sends that request to a fast, lightweight model, and you get a reply in a snap. But then you ask it to debug 1,000 lines of code. That same router realizes, whoa, this is a heavy lift, and it diverts your request to a deeper, more powerful thinking model to really get the job done right. It's a pretty elegant solution to that classic speed versus power dilemma. Okay, let's totally switch gears now and talk about Anthropic's Claude 4.5. Because if GPT-5's story is all about user experience and clever architecture, Claude's story is all about one thing: safety. The huge question they're trying to answer is, well, it's a big one. Can you actually build an AI that is provably safe and aligned with what we want? And to even try to do this, Anthropic had to develop a whole new safety training pipeline. They poured massive resources into testing for all kinds of bad behavior. I'm talking about things like the model trying to lie to a user or even actively trying to sabotage its own safety features. It's a level of rigorous testing we really haven't seen before. And here's the proof in the pudding. This is the data from that process. Now, the key thing to know here is that on these charts, a lower score is actually better. And you can see Claude 4.5, that's the orange bar. It scores way, way lower than all the previous versions on tests for things like misaligned behavior, intentional deception, and even self-preservation. These aren't just theories anymore. They're measurable, concrete improvements in safety. This chart shows another huge improvement, a massive drop in something called sycophancy. Now, that's just a fancy word for the AI being a people pleaser. You know, a sycophantic AI might agree with the user's really bad or even dangerous ideas just to seem helpful. Well, Claude 4.5 has been specifically trained to actually push back and be more honest instead. So what does that actually look like? Well, check out this direct quote from a test session. It's kind of incredible. The AI literally stopped the user and said, "Okay, I'm going to stop you there. I think you're testing me." It identified that the person was being insincere and just called them out on it. It refused to play along. That's a level of directness that, frankly, we just have not seen from an AI before. Okay,
So you have this super flexible model in GPT-5 and this really direct safety-focused model in Claude. So how do they actually stack up head-to-head when you just give them a raw, difficult task? Let's look at a pretty high-stakes scenario.
This chart comes from a cybersecurity challenge where the AI was tasked with finding and exploiting software bugs, a job that requires some seriously deep technical reasoning. And what's amazing here is that it shows that a focus on safety doesn't mean a lack of power. Look at Claude 4.5 in orange. It's significantly outperforming all of its predecessors with the highest probability of success. So yeah, it's not just safe, it's also incredibly capable. And this really gets us to the heart of the debate in AI development right now. GPT-5 is designed for maximum usefulness, a great user experience. Claude 4.5 is designed for maximum predictability and safety. So the question isn't just about which one is smarter, it's about what kind of intelligence we actually want to build. Is the end goal a more powerful tool, or is it a more trustworthy one? So where does all this leave us? Well, the fact that these two very different models are being developed at the same time shows that we're at a really critical moment, trying to navigate this new frontier between raw capability and intentional control. So let's just quickly recap the main takeaways here. First, it's obvious LLMs are evolving at a totally breathtaking pace. Second, GPT-5's big innovation is that router architecture, which is all about optimizing the user experience. Third, Claude 4.5 is prioritizing proofable safety through these incredibly exhaustive tests. And finally, and this is the most important point, the whole debate is shifting from which AI is the best to what values are we actually building into them. And that really leaves us with one last big question to think about. As these digital brains become exponentially more intelligent, what should we as users, as a society, what should we demand from the people who build them? Is the future all about the endless pursuit of raw power, or is it about the careful construction of provable safety? That choice is going to define the next era of technology.